Okay, today we are going to talk about vectors. Okay, a vector is a directed line segment. A vector has both a magnitude and a direction. Okay, we will first take a look at the vector that's represented on this whiteboard here. So we take a look at this vector PQ. For this vector PQ, the direction is indicated by the arrowhead, and the length of this line PQ will represent the magnitude of this vector PQ. So any vector can be represented by a column vector. Okay, what do we mean by that? We take a look at what is given over here. So for this vector PQ, to move from P to Q, you have to move 2 units to the right. Okay, followed by 3 units in the positive y direction. So in this case, by moving 2 units in the positive x direction, okay, we can represent this vector PQ by the column vector 2, 3. So the 2 will represent the x component, that means the x coordinate. And the 3 below will represent the y coordinate. So if you are moving a certain units in the positive x direction, this will be positive. And if you are moving in the negative x direction, okay, you will have to include a negative sign in front of the 2. So the same thing also follows for the along the y axis. So if you are moving 3 units in the positive y direction, it will be positive, and you are moving in the negative y direction, it will be negative. Okay, now this one is we will take a look at how we find the magnitude of this vector PQ. To find the magnitude of this vector PQ, we can represent it, we can denote it by PQ, okay, with a pair of vertical lines enclosing it. So to find the magnitude of PQ, we can actually apply Pythagoras theorem over here. Okay, so in this case, you can take 2 squared plus 3 squared, then square root. So you'll get square root 13. Okay, so the general formula for finding the magnitude of any vector is given by the formula. Okay, the magnitude to find any magnitude of any vector is given by x squared plus y squared, where x squared and y squared actually represent the x coordinate and y coordinate represented in the column vector. Okay. Now we'll move on to talk about equal vectors and opposite vectors. Okay, let's say in this case we take a look at the vector PQ and AB. Okay, vector PQ and AB, they are only equal to each other, okay, provided that they have the same magnitude and same direction. Okay, so only when they have the same magnitude and same direction, we can say that vector PQ and AB are equal. So as to say that if these 2 vectors are equal, if we represent them as a column vector, see PQ equals to AB, okay, where this represent the column vector for PQ, and this represent the column vector for AB, we can say that P is equals to A and Q is equals to B. Okay. Now we'll take a look at opposite vectors. Okay, you can take a look that at these two vectors PQ and AB. In this case, let's say PQ I represent. You can look carefully at vector PQ and AB. The only difference is, even though they have the same magnitude, but they have different direction. So we say that PQ and AB, they are opposite vectors of each other. If you want to actually represent that PQ and AB, they are opposite vectors of each other, you just write PQ equals to negative AB. So this negative sign will indicate that AB and PQ are in opposite direction. Okay, that's how we represent, okay, vectors that are opposite to each other. Okay, now we will take a look at how we are going to perform simple addition and subtraction of vectors. Okay, let's say take for this instance, I want to add PQ plus QR. So PQ and QR, PQ plus QR. So you have to actually follow the direction that is indicated. So PQ plus QR. Actually, going from PQ to QR, okay, there is a shorter method which involves going from P directly to R. So you take a look at this blue line here. So PQ plus QR is actually the same as going from P to R. So this is called the resultant vector, which I represent it at C. So in this case, PQ plus QR is actually equals to PR. Okay, if you make an observation, you can see that when you add two vectors together, you have to ensure that the terminal point for the first vector and the starting point of the second vector must be the same. Okay, the terminal point and the starting point, okay, they must be equal in order for you to perform simple addition. Okay. Okay, so I will give an example on vector addition. Okay, we take a look at the part 1 first. Okay, for part 1 over here, they ask you to add AB plus BC. So in this case, you can check that the terminal point of the first vector and the starting point of the second vector, they are the same. So you can go ahead and perform the vector addition. So AB plus BC, okay, will give you the resultant vector AC, which is indicated by this orange line. So this one you will get AC. Okay, this is how we perform vector addition. Okay, then I'll show you part 2. Okay, now we have to perform the addition of 3 vectors. So what you can do over here is you can perform the addition based on the first 2 vectors. After you are done with this, then we add on to the last vector BD. So we take a look at, we perform the vector addition based on AC plus CB first. So in this case, AC, okay, plus CB, AC plus CB, you can, is actually equals to AB. Okay, so this one is the resultant vector. So you get equals to AB, but don't forget there is still a plus BD behind. So after you're done with this, now you take a look at AB plus BD. So AB plus BD will give you AB plus BD will give you AD. So the resultant vector will be simply AD. Okay, that's how we perform the vector addition of 3 vectors. So you have to perform the vector addition for the first 2, based on the first 2 vectors before you add the third vector. Now I will show you how to carry out vector subtraction. Okay, we take a look at the vectors I drew on the whiteboard. So you have vector A and vector B. You're supposed to carry out the vector subtraction of these 2 vectors. So in this case, I want to perform A minus B. Okay, to perform A minus B, we take a look at minus B first. Okay, for minus B, just now when we talk about negative vectors, we just now we say that what is the relationship between minus B and B? Okay, minus B and B, minus B is just the vector that is in opposite direction to this existing vector B. So in this case, A minus B you can rewrite as A plus minus B. So after that, we take a look at minus b. Minus b means you reverse the direction for this vector b. So now I will change the direction for vector b. So if you take a look, this is b. A plus minus b is actually the same as. So now this one becomes minus b. So minus b plus a will gives you, okay, the resultant vector, which is indicated over here. So minus b plus a will gives you a minus b. Okay. So over here, I just rewrite the vector subtraction as an addition of two vectors. Okay, we can take a look at another example. Okay, as shown in this diagram, you have the vector p and q. I want you to find the resultant vector that's indicated by this blue line. So to find this blue line, we have to actually observe the arrowhead first, which is going from bottom to top. So over here, we can, to get this blue line, we can perform the vector addition of two vectors, which is, we are going from, let's say now, I just indicate the vertices over here, A, B, and C. So to get AC, okay, we can go from A to B plus BC. But if you take a look at AB, the vector AB is in opposite direction to the vector P. So AB will be negative P. So we minus P plus BC, which is represented by Q. Okay. So if you want to actually rewrite this, you can write Q minus P, which is the vector subtraction of two vectors. Okay, we'll take a look at another example. Okay, as shown by this triangle ABC, I want to get the resultant vector AC. So AC, to get AC, I can perform the vector addition AB plus BC. But in this case, if you take a look at the arrowhead, AB is in the opposite direction of vector P. So that means AB is just simply minus P, okay, the negative vector of P. Plus BC is again in the opposite direction to vector Q, so it will be negative Q. So after this, of course, you can simplify, you'll get minus P minus Q. Okay. Now we will take a look at how we perform scalar multiplication of a vector. Okay, we take a look at the vector A, B, and C, D. So in this case, this vector A will indicate that these two vector A, B, and C, D are in the same direction. Okay, but if you take a look at A, B, and C, D, this number in front of the vector A will tell you the magnitude. So in this case, AB has a magnitude of 1 and CD has a magnitude of half. So we can say that AB is twice of CD. Okay, so these two over here, which is represented by the constant, normally is represented by constant K, will tell you that, okay, this one is a scalar multiplication of the vector CD. So scalar multiplication, if you take a look, we can see that if we write AB equals to 2CD, there are two information that we can conclude. The first one will be when a vector is a scalar multiplication of another vector, they are parallel to each other. Okay. Then the second thing is okay. Depending on the situation, okay, I'll use another example to illustrate the second point here. Okay, let's say for example now you have vector AB, okay, and C happens to be lying on the midpoint of the vector AB. Okay, so we can say over here that AB is twice of AC. So based on this very special case that C is lying on the midpoint of the vector AB, we can say that of course AB and AC, they are parallel to each other. And over here you can also conclude that A, B, and C are collinear. That means they lie on the same straight line. Okay, this is what you can draw when you say that a vector is a scalar multiplication of another vector. And now I'll move on to the last part of this topic, which is the position vector. Okay, for position vector, we are talking about vectors that are drawn on the Cartesian plane, which is the x and y axis. So in this case, let's say for example, we have a point, a vector P and vector Q, and this one happens to be so in this case, if I want to find the vector that's indicated by this blue line here, the resultant vector, and I indicate this one to be O, A, and B. So how do we find the vector AB? Okay, to find the vector AB, we can rewrite as two position vectors. Okay, based on the arrowhead, AB is actually equals to AO plus OB. So we know that OA from this OA is the vector P and OB is represented by vector Q. So AO is actually the negative vectors of OA. AO is a negative vector of OA, so that means we will write this one as minus P plus OB, which is Q. So if we rewrite, it's actually Q minus P. So you can see that any vector that is represented on the Cartesian plane can be rewritten as the vector subtraction of two position vectors. Okay, because these two are actually position vectors. Okay, Q is OB minus P is actually OA. So from the result, there is indicated over here, AB can be written as the vector subtraction of two position vectors, OB minus OA. So that will conclude the topic for vectors.